Today we're going to be learning how to factor expressions. So let's go ahead and get started. I want to start with a little bit of review because we need to go over simplifying a basic expression before we get started. So don't forget that Mama distributes, and here she is, our little nest, and the baby birds in the nest, and Mom is going to distribute evenly. And that's going to apply to B and C. So go ahead and pause the video and see if you can work through simplifying these expressions. And I'm going to go ahead and get started on them. So I notice I'm looking for like terms on A, and I notice I have a 3x here. And I have a negative x or a minus x right here. Those are my like terms. I'm going to underline the plus 5. It's its own, kind of its own man. So let's go ahead and rewrite those together. So I have a 3x, and I'm going to be including the operation signs minus x plus 5. So I use commutative property to put them together. 3x minus x. I have 3 x's. I take away an x. Now I have 2 x's left plus 5. So that's there for the first one. Let's use a little Mama distributes here. Mom is going to distribute evenly to the babies in the nest. I have a baby Y and a negative baby Z. And Mom is going to feed both of the babies. So we have x times y, excuse me, plus, oh, excuse me, that's not a plus, is it? So minus, I notice I have a minus sign here, x times z. And I'm done. There are no like terms that I can combine. That's as far as I can go. So Mom is going to distribute down to C. Mom will distribute evenly. Now it looks like Mama Bird has gained a little weight. We've got a 3y here. Don't let that trip you up. Remember that a y is just a number we don't know, and since we don't know it, we're not going to mess with it. We'll just say 3y times 4x. Well, I know that 3 times 4 is 12. And then I don't know what x and y are, so we'll just write them down. This is the same as 3 times 4 times y times x. And then I'll distribute my 3y to the 2. 3 times 2 is 6, and we can't forget our y. We have 6y. Okay, so let's get on to our lesson. So factoring, guys, is a method to find the basic numbers and variables that made up a product. So we are basically looking at the end result and pulling everything out. And that's going to make sense in just a little bit. So we just reviewed how to use a distributive property. Now we're going to do everything in reverse, guys. The process, we're going to reverse that process and create an equivalent expression in a factored form by using the distributive property. So let's see what that looks like. Basically, we're reversing the process. I've said that a couple of times. And here's this guy. I love this. There he goes. He's reversing the process. So before with distributing, you might think of it as we were sliding down the hill. Now we're going to go right back up the hill. So I'm going to ask you to factor 18 plus 30. Let's go through the steps to do that. The very first thing that we need to do to build a factor is to find the greatest common factor. You guys know 2 different ways to do that. You can use factor lists or you can use a factor tree. I'm going to use a factor tree. You may also be to the point where you know how to do this without, you just know the greatest common factor just by looking. But in case you don't, let's go ahead and start working on this. So I have 6 times 3 are both factors of 18. 3 is a prime number, so I'll circle it. And then I have 3 times 2. And these are both prime numbers, so I'll circle them. And so maybe I'll write up here, 18, this is the prime factorization, equals 3 times 3 times 2. That's supposed to be a times. It looks like a minus. Okay, now let's factor our 30 off to the side here. I'm going to start with a 3 times 10. That's the easiest one for me. So I'll circle my 3, it's prime factor, it is a prime factor. And then I know the factors of 10 are 5 and 2, and that's as far as I need to go. So we'll circle them, and we'll rewrite the prime factorization up here. 30 equals 3 times 2 times 5. So now I'm going to look and see, what do they share? We share a set of 3's and we share a set of 2's. 3 times 2 equals 6. So our greatest common factor is 6. Let's continue on here. We found the greatest common factor of 6. For step 2, we're going to rewrite this expression using the greatest common factor. In other words, I'm going to look and say to myself, 6 times what is 18? 6 times 3 is 18. 6 times what is 30? 6 times 5 is 30. So I have just rewritten this exact expression and in a factored form here. 6 times 3 is 18. Yep, that's true. Plus 6 times 5 is 30. It's just an equivalent expression, guys. I have one more step to this process. So here was a first step. We pulled out the greatest common factor. Now we've broken it down into its little parts. The very last thing, we're going to use the distributive property in reverse. Mama gives, but she can also take. I don't know if your mom has ever taken anything from you, but mamas can definitely take. So here's my little baby. Oh, mama takes. There we go. Mama gives, but she takes. So I'm going to pull 3 completely out of that expression and put the baby birds in their nest by themselves, and the 6 has been taken out. So guys, if I wanted to check that and make sure that I knew that this was right, I can redistribute. 6 times 3 is 18 plus 6 times 5 is 30. So it looks like I got it. That is exactly the same as what I started with. So let's of course try some other examples. So remember, Mama can give, but she can also take. I need to find the greatest common factor between 3 and 42. And I am actually going to use my divisibility rules. I could factor this all out, but looking and seeing that I've got a 3 here, I'm just curious if 3 can go into 42. So if you remember our divisibility rules, if I find the sum of these 2 digits and 3 can go into that sum, then they will be divisible. 42 will be divisible by 3. So if I go 4 plus 2 is 6. Yep, 3 is a factor of 6, isn't it? So 42 is divisible by 3. So I know right off that that's going to work. So I'm going to use my distributive property in reverse. Since I said 3 is the greatest common factor, I'm going to pull 3 out of each of these terms. So 3 times what is 3x? 3 times x. Maybe I'll do this in parentheses. 3 times x is 3x. Plus 3 times what is 42. And I might have to work this off on the side and see if I can figure it out. So I have 3 times 14 is 42. Okay, so I'm not quite done though. Mama gives, but she also takes. Mama's going to take these 3's completely out of the nest, leaving the baby birdies all alone. So 3 is on the outside of the parentheses. Then I have x plus 14. And then I'm going to check my work and make sure that I did it right. 3 times x is 3x. Yep. 3 times 14 is 42. Yep, I did it right. So let's try the next one. So I need a greatest common factor for these. This one's going to take me a little bit more work, I think. I might do a factor tree here. So let's start with a 3. 3 times 21. And then 7 times 3 And I've got it, so I'm going to write it up here. Well, sorry. 63 equals 3 times 3 times 7. Okay, let's try 27. 9 and 3. 3 is a prime number, so I'll keep going with my 9, and I have a 3 and a 3. So for my prime factorization of 27, which I'll write right underneath, 27 equals 3 times 3 times 3. I'm sharing two sets of 3's. I'll go ahead and circle those the best I can. 3 times 3 equals 9. So my greatest common factor for these two terms is 9. So now that I know that, let me go ahead and clear this off so we have some more working space. Now that I know that, I'm going to say 9 times what is 63. So 9 times what is 63? Not just 63, but 63z. 9 times 7 is 63, and then I need my z. 9 times 7 is 63z. Minus 9 times what is 27? We should, again, 27y, I'm getting sloppy. So 9 times 3y is 27y. So let's go ahead and pull that 9 completely out, because Mama gives, but she also takes, so I have my 9 completely pulled out. 7z minus 3y. This is supposed to be a 7, guys. That's a weird looking 7. Okay, so let's check our work. 9 times 7z is 63z. 9 times 3y is 27y. So I went and I checked my work to make sure that I was good. I have one final problem here. This is a story problem. We love these word problems. Mrs. Wolfenden's homeroom got a discount when they bought pizza. The original price per pizza was X dollars, so we don't know how much the cost of the pizza is. They bought 5 pizzas for a total of 5X minus 15. Factor the expression, what was the discount? So, step 1, what's the greatest common factor? Hopefully you can tell that it's 5 right off. So I'm going to pull the 5 out. 5 times what is 5x? 5 times x is 5x. Minus 5 times what is 15? 5 times 3 is 15. So Mom is going to pull that 5 completely out, leaving those baby birdies alone in the nest. X minus 3. So remember that the cost of the pizzas was X dollars, so we know that this X is the cost of the pizzas. So what is the discount? The only thing that's left is this minus 3. So my discount was $3 for each pizza.